Welcome back to Josh Does Math. In this video we're doing another limit problem. This one involves the square root here. And we're also looking at the limit as x goes to infinity. So here's the problem. Limit as x goes to infinity of x over the root of x plus 1. So how do we do this? Well, let's just plug in infinity and see what we get for our value. So we end up getting infinity over infinity plus 1. That's just infinity. And then we're taking the root of infinity, which is also just infinity. And we get infinity over infinity, which some people might say, oh, infinity divided by infinity, that's just 1. But because the nature of infinity having the possibility of taking on different values, we don't know for sure that that is 1. So we can't say anything about it. It's an indeterminate form. So what do? Well, if this was 0 over 0, we'd look for a factor in the numerator that cancels with a factor in the denominator. And we're kind of doing the same thing here. So we're looking at limit as x goes to infinity. And in the denominator, let's say that we cancel, let's say that we factor out a root of x. So in the denominator, this will look like this. We can write x plus 1 as x times 1 plus 1 over x. And then we can rewrite this as pulling that x outside the root. So that ends up becoming root of x times that under the root. And in the numerator, we still have x, which, okay, we can write that as root of x, root of x. Doesn't matter how you think of it, but we're going to be now canceling this root of x in the numerator and denominator. And we're left with limit as x goes to infinity of root of x all over root of 1 plus 1 over x. And the trick was to get our denominator to have this 1 over x down here. Because now, whenever we plug in infinity, we know that 1 over a number that is approaching infinity is just 0. So we plug in infinity in the denominator, we get 1 plus 0. In the numerator, we get the root of infinity, which is infinity. Simplify this. Denominator is 1 plus 0, that's 1, and the root of 1 is 1. Infinity over 1 is infinity. So you actually do end up with infinity as this limit. And depending on different contexts, sometimes infinity is considered to be does not exist for the limit, and sometimes you'll be expected to say the limit is equal to infinity. Usually you say the limit does not exist, but this limit does not exist because it approaches infinity. So that's how you do this kind of limit problem. Thanks for watching.